Okay, let's take a moment to correct a small issue that's present in our setup. Look at our toolpaths. We've got 3 of them. The facing operation that skims off the top, then the 2D contour and the 2D chamfer. The issue is that we've already done one of these steps. We've already cut the metal off the top of our stock. So let's separate that step from the other 2. Right-click on your setup and choose Duplicate, and then click once on your first setup, wait a second, and click again on the name to rename it, and call this one Face the Top, and rename your second setup 2D Contour the sides and Chamfer the top. And then delete your duplicate toolpaths such that your first setup only has the facing of the top, and your second setup only has the 2D Contour and the 2D Chamfer in it. Good. This better represents reality. First, we faced the top. Then we pulled material out of the mill to inspect it. Now we're going to put material back in the mill and contour the sides and chamfer the top. And this isn't just because we love being neat and tidy. It's necessary. Do you remember how we faced the top? Well, first we probed it. And what did we probe? We probed the top of our raw stock. And that material is gone. So we can't put this partially worked cube back in the mill expecting to probe the same surface. It doesn't exist anymore. We milled it away. But back in Fusion, we've got this problem. Our work coordinate system, this point right here, is positioned on our raw stock as though the metal were still there. This is what we get to fix by breaking our toolpaths into 2 different setups. So let's fix it. Double-click on your second setup to edit it, and click on the Stock tab, and look at this stock top offset. It used to be set at 40 thou, which represented our raw stock that we were going to cut away. We've done that already, so let's set it to 0. And watch how when you set it to 0, our work coordinate system moves down 40 thou, down to the very top of our model, the clean, machined surface that we've already created, the surface that we can actually touch with the probe when we put this back in the mill. And if we simulate this second setup, we should see that it starts right at the 2D contour and then does the 2D chamfer, and it skips the facing operation. Go ahead and click the post-process button for this setup, and let's change the name of the program from 1001 to 1002, the second thing that we're doing. Click the post button to generate your G-code, and look at how now our G-code has 2 tools, T1 and T12, and both of them get a Z-min value. So ask yourself the same question you did before. Am I comfortable descending from 0? And at this point, 0 is the top of your machined surface. That's what we're going to probe. Am I comfortable descending negative 0.64 inches for T1 and negative 0.05 inches? And you can ask that when you step up to the mill. And notice how our toolpaths are recognizable, but they're not the friendliest names. So I want to go back and rename them. Let's call the first one Contour the Sides, and let's call the second one Chamfer the Top. Then repost that G-code, right-click on your setup, post-process. But notice how when I renamed this 1002, it didn't stick. So let's fix that. Cancel the post, double-click on your setup, and go to the post-process tab and change it here. This is a more permanent way to rename your G-code every time you post. There we go. Now this setup will always create a program called 1002. And if I hit the post button now and look at my G-code, I can clearly see each of my toolpaths, and I can see that they're mine. And now that I've been around the block once of posting G-code, let's dig into it a tiny bit more. Look at my 2 Z-min values, negative 0.64 and negative 0.05. The more interesting one is the negative 0.64 because it's bigger, it's further down. It puts my vise and my mill more at risk. Let's find that location where we arrive at negative 0.64 down in our actual G-code. For me, I'm using Visual Studio Code. It's a free and useful editor for looking at all sorts of programming code. If you've already got a text editor that you like, great, use that one. If you don't, go ahead and download Visual Studio Code so that you can follow along precisely. All that I want to do at this point is search by hitting Command F for occurrences of Z followed by the minus symbol. Here, the first occurrence says Z minus 0.4625. This corresponds to this moment in the Fusion simulation where my tool is plunging down to its initial cut. The next occurrence is one line further down, right here at Z minus 0.5, just a little bit lower. Notice how this Z minus line is not all on its own. It's connected to a move on X, and you can see it here in Fusion, where we get a little lower and we get closer to our material as the tool moves to the right on X. And then there are many lines of G-code with no occurrences of the letter Z at all. This is where the tool is going around the 2D contour at the first of its multiple depths, half an inch down from 0. If I modify my search so that it says Z minus 0.64, I'll find my way to the line of G-code where I descend to my Z min value. This corresponds to my second loop around the contour of my cube at the second of my multiple depths. I really like digging into G-code because I like understanding how each of these systems work. If staring at this text code stirs terror in your heart, don't worry. We're really just trying to develop a strategic approach to not crashing the mill. You're trying to ask the question, how low am I going to go? And is there anything down there that I might crash into? You're trying to develop a sense of when you're past the area of elevated risk. Descending towards big, heavy metal objects is riskier than ascending away from them. Changing tools resets the risk game. Descending again with a new tool is risky. Ascending away is less so. As a beginner, it's probably going to feel like all risk all the time. That's a great mindset. That'll keep you going slow and hitting the feed hold button a lot.